Hello everyone and welcome to UK Foundations. This is Uthara Adithi and today we are going to be starting the short answer questions of chemical reactions and equations. In the previous video we have done about the MCQs, so definitely go through that as well. So let's begin. What is the first question? Right. Write the balanced chemical equations for the following reactions and identify the type of reaction in each case. So the first one is nitrogen gas is treated with hydrogen gas um, in the presence of catalyst at 773 kelvins to form ammonia gas. Ammonia formula is NH3. Ammonia gas. Okay, so this is a very special type of reaction. It is also called as Haber's process. A piece of information. Haber's process. Okay, so this is a very important one in the future. We'll be learning about it. So let's balance it. N2. So nitrogen is 2 right here and there's 1 here. So let's drop a 2 here. And there is now nitrogen is balanced. Hydrogen is 6. So drop a 3 here. This is the balanced equation. N2 plus 3H2 gives rise to 2NH3. So here you'll have molybdenum and all. So that is the important one. First is done. Next, second one. Sodium hydroxide solution is treated with acetic acid to form sodium acetate and water. And also in the first one they've asked the type of reaction, right? So what is the type of reaction? It is a combination reaction, as you all can see. It's a combination reaction. Next, so the second one is sodium hydroxide with acetic acid, CH3COOH. This is the formula. Give rise to CH3COONA plus water. Okay, you can remember like this is removed, actually not this. Okay, and N comes in place of H and this H and OH will combine. So this is a type of neutralization reaction and it is balanced as well. Let's take a different color. Next, ethanol is warmed with ethanoic acid to form ethyl acetate in the presence of concentrated H2SO4. So ethanol is C2H5OH, C2H5OH plus CH3COOH. This is ethanoic acid. Okay, it will form like the previous one only. It will form CH3COO, C2H5 plus water. This is also a neutralization reaction. So this H, actually this OH from here and a H from here is removed and C2H5 occupies this H's position and this reaction takes place. This is also a neutralization reaction. Moving on, ethene is burnt in the presence of oxygen to form carbon dioxide, water and releases heat and light energy. So ethene is C double bond C2H4. Okay, so this C2H4 is burnt in the presence of oxygen, so you can write plus O2 to form carbon dioxide and water. To form carbon dioxide and water, right? So let's balance it. Here in short you can write it as C2H4 as well. Carbon is 2 here and there is 1 carbon over here, so you can drop a 2 here. And if you see for hydrogen, there is 4 hydrogens here and 2 over here, so you can drop a 2 here. And oxygen, 2 2s are 4, 4 plus 2 5 6, so you can put a 3 over here. So you'll have C2H4 plus 3O2 gives rise to 2CO2 plus 2H2O. Okay, next question. What is the next question? Write the balanced chemical equations for the following reactions and identify the type of reaction in each case. So thermite reaction, we have ferric oxide with aluminium to give molten iron and aluminium oxide. This is simple, right? Fe2O3 plus aluminium gives rise to Fe plus Al2O3. Gotta balance it. And what type of reaction is this? You can tell it's a displacement reaction and also it's a redox reaction as well. Okay, so iron, drop a 2 here. oxygen 3, aluminum 2 here, so there's a 2. So 1 2 2 1. Okay. Next, magnesium ribbon is burnt in the atmosphere of nitrogen gas to form so a solid magnesium nitrate. This is also easy. Mg plus N2 gives rise to Mg3N2. So 3 over here to balance it. This is a combination reaction. Easy, right? Okay. Next, chlorine gas is passed in the in an aqueous potassium iodide solution to form potassium chloride solution and solid iodine. So Cl2 plus potassium iodide Ki gives rise to KCl plus I2. Okay, it will be better if you also mention the states like gas, and this is an aqueous, then to form solution, and this is a solid, so you can mention that as well. So there is 2 chlorine here, put 2 here, potassium 2, iodine 2, so 2 balanced. 1 Cl2 combines with 2 moles of potassium iodide to form 2 moles of KCl and I2. Ethanol is burnt in air to form carbon dioxide, water, and releases heat. Okay, ethanol is C2H5OH with carbon dioxide. No, is burnt in air. Sorry, C2H5OH is burnt in air to form carbon dioxide and water. So there is 1 carbon here and 2 carbons here. You can put a 2 over here, 2 CO2, and hydrogens, if you see, 5 plus 1 6 are there, so put a 3 here. Oxygen is 2 2s are 4, 4 plus 3 7, and here there is 2 plus 1 3, so you can put here you can put a 3 here. 3 2s are 6, 6 plus 1 is 7. I think it's balanced now. Yes, you have to write it in the steps which is mentioned in the textbook, right? You have to draw boxes around each of them and that type of balancing. This is just a short video. Okay, moving on with the different color. Right, complete the missing components and variables given as x and y. In the first thing, lead nitrate with potassium iodide gives lead iodide plus KNO3 potassium nitrate. So x and y, here x is solid and y comes out to be aqueous. You have to be aware of it. Solid and aqueous. Next, copper reacts with silver nitrate to give copper nitrate and X. It's very easy, right? You can do by this also. Copper and nitrate is over. Remove copper and nitrate. Silver is there. Just in place of X, silver. You have to write it in the balanced form. So here there is 2 Ag. Drop a 2 here. That's it. Balanced. Okay. Next, zinc plus sulfuric acid gives zinc sulfate plus H2. So here Y will be gas, as you all know. Simple, right? And then the previous one, zinc sulfate, X will be aqueous. Okay, aqueous solid. It's giving you an aqueous solution and a gas. Next, calcium carbonate gives rise to calcium oxide and carbon dioxide. This is a decomposition reaction, so it will be taking place in the presence of heat. If you know, heat is represented with a symbol of like a triangle, delta. Okay, so you can write that, or you can write heat. Heat is being supplied. So is it an exo or an endothermic reaction? It's an endothermic reaction. It's absorbing heat. Moving on. Which among the following changes are exothermic? Okay, is it exothermic or endothermic? So first one, decomposition reaction of ferrous sulfate. So ferrous sulfate is FeSO4. So the decomposition of ferrous sulfate. Decomposition means breaking down into its respective compounds, right? So decomposition always involves absorption of heat energy. So it's endothermic because you have to break the bonds. So it is endothermic. Okay, dilution of sulfuric acid. If you have gone through the previous video of MCQs, you'll know that dilution is always an exothermic reaction. Exothermic. Dissolution of sodium hydroxide in water. This is an exothermic reaction. Dissolution, it is exothermic. Forgive my handwriting. It's an exothermic reaction. And the last one, dissolution of ammonium chloride, is an endothermic one. Endothermic. Okay. Hmm. Oh, right. Identify the reducing agents in the following reactions. So again, in the previous video I mentioned about the reducing agents and the oxidizing agents. Reducing agents again are the ones that itself undergoes oxidation, means addition of oxygen or removal of hydrogen. Okay, so on the basis of that, 4NH3 plus 5O2 gives rise to 4NO plus H2O. So let's check it with NH3. NH3 is it's too clumsy, wait. Okay, NH3 is gaining oxygen, means nitrogen is gaining oxygen, it means it's oxidation. So that is the reducing agent, got it. What about this one? Oxygen is gaining hydrogen actually. So it is reduction, that means this one will be an oxidizing agent while this is a reducing agent. Finally, it's a redox reaction. Redox reaction. Okay. Okay. H2O plus F2 gives rise to HF plus HOF. So now if we see fluorine right here, actually water, if you check over here, what is happening? It is losing in hydrogen. It is losing in hydrogen and actually it's gaining fluorine also. If you go with this, it's gaining of hydrogen. Okay, and check with this, it's gaining of oxygen and hydrogen. So right, here water is actually acting as an oxidizing agent. Oxidizing agent. So fluorine will be a reducing agent. Okay, right, I hope it's clear. Next, Fe2O3 plus 3CO gives rise to 2Fe plus 3O2. Again, reducing agent is the one that undergoes oxidation. Speaking about Fe2O3, it's losing of oxygen, so it is reduction. It will be oxidizing agent. While CO is gaining oxygen, right? From one oxygen, it's going to two oxygens. Like if you go with even the stoichiometric coefficients, from 3 it's going to 6. Right. So it's gaining of oxygen, so it is a reducing agent. Carbon monoxide is a reducing agent right here. And over here, hydrogen is gaining oxygen, oxygen is gaining hydrogen. You can look in that ways. So because hydrogen is the one that is gaining oxygen, it's undergoing oxidation. So this is the reducing agent. Reducing agent is hydrogen. Okay, moving on. Hmm. Okay. Identify the oxidizing agent in the following reactions. Again, oxidizing agent is the one that undergoes reduction. We'll do some specific set of questions because it's repeated. Okay, so let us do the first three ones, or let's do alternatively. How about that? Okay, and the rest of them I want you to comment about the second one, fourth one, and the sixth one. Okay, so let's make it a little bit of an interactive session. We'll go with the first, third, and this first, third, and the fifth. Okay, yes. Oxidizing agent, again, it undergoes reduction. Let's write it like this. Okay, lead is losing oxygen, so it's basically reduction. So it's Pb3O4 itself. Clear. Next, the third one, copper sulfate plus zinc gives copper plus zinc sulfate. Copper sulfate right here, it's losing of oxygen. It's losing oxygen, so it's undergoing reduction. So it's copper sulfate only. Luckily, we are having the first ones itself. Here, iron is gaining oxygen, so it's oxidation, not here. Water is losing oxygen, so it's undergoing reduction. So here, water is the oxidizing agent, or it's the oxidant. These are the answers. Again, I want you to comment about the second, the fourth, and the last one, sixth. Okay. Write the balanced chemical equations for the following reactions. We have to write a balanced chemical equation. Let's try the best to do that. Okay. Sodium carbonate on reaction with HCl is giving sodium chloride and sodium hydrogen carbonate. Na2CO3 plus HCl give rise to NaCl. Because I don't have space, I'm writing like this. NaCl plus NaHCO3. Okay, it's balanced already, right? So it's balanced already, so just to write the reaction you can write it, and you can explain why it is balanced. You can, if I have to tell, there's two sodiums here, sodium, sodium, two sodiums, one carbon, three oxygens, one chlorine, hydrogen, one and one, balanced. Okay, next, sodium hydrogen carbonate NaHCO3 and reaction with HCl gives sodium chloride, water and CO2. NaHCO3 is reacting with HCl and it's giving NaCl, water and CO2. Okay, is this balanced? Yes, I think so. Sodium 1, hydrogen 2, 2 hydrogens, carbon 1, oxygen 3, chlorine 1 and 1. I think it's balanced, and yes it is. Great. Next, copper sulfate CuSO4 on treatment with potassium iodide gives copper iodide and an iodine gas. Okay, and also it forms potassium sulfate. So let's write down this reaction: copper sulfate CuSO4, or maybe let's just zoom it on. How about this? Right, we can use this space. Copper sulfate CuSO4 with potassium iodide gives rise to CO2I2 and potassium sulfate. Okay, so let's balance it. 1 copper, 2 copper, so drop a 2 here. Okay, next, so sulfur, let's see, 2 sulfurs and here 1 sulfur, so we gotta drop 2 here as well. Okay, and 8 oxygens here, 8 oxygens, well balanced. Copper balanced, sulfur balanced, oxygen balanced. Potassium 1, potassium 4 over here, and automatically iodine is balanced because 2 plus 2 is 4 and 4 1 is 4. Okay, potassium is also balanced, iodine is also balanced. So okay, right, moving on to the next question. 26. A solution of potassium chloride when mixed with silver nitrate solution, an insoluble white substance is formed. Write the chemical reaction involved and also mention the type of chemical reaction. So I think we have to zoom on again. Just a minute. Okay, let's utilize this space for it. I just like using different colors. Okay. So it is potassium chloride KCl. It is reacting with silver nitrate AgNO3. So you know that it's a double displacement reaction. It gives AgCl plus KNO3. Okay, so now this is balanced, and they're telling an insoluble white substance, that is basically a precipitate. AgCl is a precipitate, and henceforth this is a precipitation reaction. You should write precipitation, and also you should write it as double displacement. Forgive the writings. Okay, next, 27. Ferrous sulfate decomposes with the evolution of a gas having a characteristic odor of burning sulfur. Write the chemical reaction involved and identify the type of reaction. I think this is an interesting chapter. We'll have a lot of interesting questions right here. Okay, maybe this will be our last question, and the next question will be coming in the next video. Okay, so let's solve the last question for now. Ferrous sulfate, 2 moles of FeSO4. Is this color visible, or take up a little different color? Let's take blue. Ferrous sulfate, when you provide heat, it's decomposing to form Fe2O3, SO2 and SO3. Okay, So this is given in the textbook itself. So just balance it, 2 modes of Fe. So what type of reaction is this? Decomposition in the presence of heat. Okay, so the characteristic burning odor of this thing is because of these gases. Okay, and if you remember, it was 7H2O. It loses its color. It was in green color. It lose the color because of heating, right? Water, the crystallization and all of that will come here. Okay, for now we are done. Okay, the rest of the questions from 28 right on to 34, 38 will be coming in the next video, and the long answers will be in the other video. Hope you all enjoyed this one, and definitely comment on the homework question that I have given. So thank you. Definitely spread the key of success, spread knowledge. Thank you.